Hi, Nick.
Hey, Chakri, how you doing?
Hi, everyone. Can anybody confirm me whether you can hear me or not
Yeah, I can hear you, Chakri. Thanks for joining.
on the chat window?
Hello, everybody, and welcome to today's meetup on microservices on OpenShift. Today, we'll be having Chakri Janganam presenting for us. If at any time you have any questions, feel free to ask. Everybody is muted by default, but you can go ahead and unmute yourself if you'd rather speak, or else just enter it in the chat. With that, take it away.
All right. Thanks, Nick. Thanks, everybody, for joining. Today, we are going to discuss how we can deploy microservices on OpenShift. Basically, I'm going to cover a few background on what is microservice, but this is not essentially a topic on what microservices are and why we should use microservices. But this is essentially how to deploy microservices on OpenShift. So I'll give a very short intro to microservices. I want to start with an example, like consider Amazon. If Amazon was a company, I would assume like each service on their website, like orders, wish list, or suggestions, all those services can be deployed independently. All these can be made into small microservices, which can be written in different languages, not just one particular language, but in different languages. They can be developed independently, deployed independently, and as well as scaled independently. This way, companies get benefit of working in smaller teams rather than having one big monolith app. Um, so all these microservices typically communicate over a lightweight HTTP protocol. That's how they will be in sync. But otherwise, you can assume each small business entity can be a microservice, and they can be developed independently. So these are, as I listed, some of the main features of microservices. They are small, easy to understand and maintain. They can be deployed and scaled independently. Rollback is easy because if some microservice goes down, whole entire system doesn't go down. Only that part becomes down. So that way, rollback is very easy. And dev teams, because small teams make productive work, that way you can leverage uh, um, some of the uses of small dev teams, and they can be working in different technologies, not just single technology. Um, yeah, these are some disadvantages. They are very little latency, and always the problem with distributed systems are we need to keep monitoring them. We need to make sure they are live. So distributed systems are always like too many moving parts, right? That way you have the problem of keeping them up and running. There is a operational complexity involved, and also automated testing becomes very important as there are too many moving parts. With this, I want to move over to OpenShift. In order to understand what OpenShift does in the space of microservices, you need to understand some of the building blocks of OpenShift. The things I show here are not necessarily only building blocks of my OpenShift. These are very like high level important building blocks, but there are many other things as well. The first thing is image streams. Image streams, if you are familiar with the containers technology, image streams are nothing but your base images or your application image, Docker images, which are built out of your organization. So they can either be a base image on top of which you deploy your application and then make a application image out of it, or it can be application image itself. So you can consider them as image streams. These are again OpenShift terminologies. And build config. All the objects in OpenShift are mentioned as JSON files or YAML files. They can be referenced like this. In this case, you can see there is a build config. Basically, when you have the image stream ready, like a base image, maybe a CentOS with your Apache server, or a Red Hat 7 server with your pre-built libraries like JBoss or your web server, any web server, that becomes your base image, and you want to deploy some application code on top of it. You use build configurations for that. So in build configurations, you just mention what kind of deployment do you want. So I want to do a GitHub source repo deployment. I mentioned the GitHub secrets and where is my GitHub source code like this. I will expand this once I'm done with I'll have more examples of this in the later screens. But typically, these configurations are just mentioned as a JSON file, right? So your build configuration, when the application is built, you will basically get a application image, and you deploy that application image using the deployment config. So deployment config basically tells what are the environment variables that it needs to use during the deployment of your application. And so all the deployment related configurations, like how many instances of your applications are needed, how many instances of your image needs to be run, all those things are mentioned inside the deployment configuration. And services are OpenShift object basically, which load balances the images, like all the traffic to application instances. So if you run multiple instances of your application, basically service will load balance all those requests to your application instances. And the last one is route. So when you have service running, if you want to expose this service outside the OpenShift environment, basically creating a domain name, you use route here. These are some basic building blocks. Then we'll basically move on to an example. This is a straightforward demo that we are going to do. Before I move on to the demo, I would check the chats to see if there are any blocks. Yeah. Okay.
Chakra, I have a question from the
Mhm.
audience here. Is the services slash deployment config something linked to HA proxy for load balancing?
So typically you can assume at a router level it is HA proxy, but at service level it's just IP tables and forwarding those requests to corresponding application containers. So it's not HA proxy at service level, but it's HA proxy at router level. Does it answer your question? Yeah. So does the YAML format of your build files follow Kubernetes format at all, or is it a unique specification for OpenShift? So so OpenShift is a wrapper on top of Kubernetes. So all the YAML specifications that you define are basically compatible with Kubernetes. So it's just a enhancements of what Kubernetes is. So you can assume um, it does follow the same format of Kubernetes. In fact, you can actually use kubectl inside OpenShift because it's just a wrapper on top of OpenShift, on top of Kubernetes. Sorry. Okay. All right. So we are going to deploy a simple application which demonstrates microservices architecture here. I want to give a big picture of what we are going to do, and then dive into microservices demo. So we are going to deploy a simple application where user registers with his Twitter username and clicks on register now. And the next thing is he logs in and he gets the authentication token. And there's a button for get friends list. Clicks on that button, and then he sees a list of friends that he has. Basically, these are all users who are registered. And when the user clicks on the get tweets button, he will be displayed with all the tweets for that user. So this is a very small, simple application for demonstrating the microservices part. In this, you need to understand that the UI which we have seen is deployed in PHP, which is basically a front end here. And the user's registration part, the API for which the user registered is deployed in Node.js, and the data is stored in MongoDB. And when the user registration is done, it will also trigger an email using the email API, which is written in Python. And these all emails are stored in a MySQL instance, and the email will be sent out to the user externally. And when he clicks on the get tweets button, he goes to Twitter feeds, which is basically a Java-based app, Java Jersey-based app, which provides the tweets of the user. So the reason why I've chosen different technologies and different databases for each of the service is to demonstrate how different technologies can combine together and become a whole set of microservices. But otherwise, you can deploy it in a single technology. That's totally fine. So I've chosen a different technologies because I want to demonstrate those features. All right. So this is a repo that I'm going to work on. This is Debian master / microservice on OpenShift. In this repo, I have one folder for each of those services. One is Java. This is a Twitter feeds API, and this is a users API, which is written in Node.js, and the UIs and the PHP, and the email API in Python. So while we are building the application, you basically go to each of these folders and deploy the application. That's the funda that I want to show. So your your whole microservices can be in a single repo, and then you can choose what to deploy. Okay, so how do you deploy the first thing is I want to deploy an email service, right? In this email service, I have a MySQL instance and a Python email API. How do I deploy a MySQL instance? It's as simple as running one single command like OC new app, and you give environment variables that it needs to start with. I'm going to use a MySQL base image that is a community built CentOS based MySQL image. You can use Red Hat secure images as well. this MySQL instance needs to know what is the username, what is the password, then what is the database it needs to start with. So this is going to create a MySQL container and assign MySQL app user as one user and with the credentials that are given here. So it creates a container which is ready to be consumed. And this
Chuck,
container, yeah, sorry,
Chuck, we have a question. How
yeah.
is how is the authentication ensured when the execution logic and registration are on two different nodes/services?
Uh, can you expand? Can you explain that more, Karthik? So, what type of authentication? So all these, as a yeah, all these services are basically confined to one single project. If you are deploying it, in the later screens, I'll show you what are namespaces and how to create projects um, inside the OpenShift environment. And also, I'll show you what kind of constraints you have between each project and how they are secured between them. All the by default, all the apps that are created inside a single project will be able to communicate with each other because that's a single namespace here. But if you have another project or another org in your company, they won't be able to communicate unless the admin gives privileges for the communication. So I'll give a short intro when we go into the demo part. Okay. I have given a typical example of how to deploy a MySQL instance and an email API here. So you start a MySQL container like this, and you use the same MySQL password and username inside the email API, the Python API. Uh, and you also mention the MySQL host, service host, where the service is running. So that way, this database and the Python microservices are linked together. So all this communication happens via environment variables. So environment variables are key in integrating the apps and databases or integrating apps and apps. Okay. So this is all this logic I'm going to explain in the demo part. How you deploy a Twitter feed API and all. This is basically all the commands that I have. I have it in the Sublime text here. So I'm going to set up some environment variables before I start. Um, Give me 1 second. I want to give a like how to install your OpenShift environment. All this can be covered in a. I'll give you at the end of the tutorial how to install that. But it's if you have Vagrant installed on your machine, it's just 2 commands to get started with OpenShift environment. I'll send those commands once I'm done with the presentation. But uh, my OpenShift environment is running on 10.2.2 This is a default port. I'm going to log in into the web console here, admin and password. So these are all different namespaces that I have for my organization. So I can create a namespace by clicking on New Project. Like for Microservice example, I'm using Micro. And from command line, I'm going to log in. So OC login, and I'll give the website URL here, admin, and then password. So by default, I'm in the Micro project. So to see which project I'm in, type OC project, I'm inside the Micro project here. And then I need to set up few environment variables for integration of services. So this is what I have. This is where my Git repo is, and this is the domain on which my OpenShift is running. and this is a project name. So the project name is micro. These environment variables are used when we build the applications. That's why I'm going to run this. Okay. Once I have the setup ready, I'm going to deploy a MySQL instance using this command. So this MySQL instance takes username, password, database. And when you say MySQL, it understands that it needs to deploy a MySQL instance. And I'm going to name it as MySQL service. Okay. So I have nothing on the project here. And then I do OC new app MySQL, and it started building that. So to see what all pods are that are running, pods are nothing but containers in OpenShift world or Kubernetes world. I say OC get pods. You can see one MySQL instance is running here. So this is, you can see it on the UI as well. This is a service, MySQL service that is running. And then I want to log into that MySQL instance container. So I can straightforward use OC RSH. RSH is similar to SSH in OpenShift world. And then you give the container name here. So currently I'm inside the MySQL container, so this container. And then what I'm going to do is I'm going to connect to the database. These environment variables are already exported inside container. So I'm going to connect to the MySQL instance. I have already connected to MySQL instance now. I'm going to create a schema for emails for which the outbound emails are stored. So I have created the email. I'm going to exit from the container. So I've created the necessary schema for MySQL to store all emails. All right. Next thing is I want to deploy the Python email API, which basically talks to this database and stores all the email contents. So for deploying emails, you need to understand that if you go to this repo, which I have here, so this is a Python email API that we are going to deploy. So this Python email API has got a requirement.txt, which basically defines what all libraries that it needs to have for running the Python email API microservice. So OpenShift is smart enough to read the requirement.txt and install all the dependencies of the application. So when I say OC new app and give context directory as Python email API, because this is the directory where it needs to go and read the source code from. So I need to give the Python email API context directory. And also I need to provide where is my MySQL host and what is a MySQL username, and that way it can communicate with the MySQL instance. And if I don't like the default Python image that OpenShift can use, I can specifically mention a version of Python image that I can use. So it's pretty flexible on what you can choose. So I'm going to create a Python email API out of this. Now you can see OC get parts. You will see one build API. So it basically created a build configuration, and it starts deploying the Python email API. Let's go back to the console and see the build that is going on here. So a build is happening for the source code that we mentioned. It has already, you can see in the logs, it has already started the application here. So email API is up and running. If you look at the logs, that what happened when we said go build email API, you can see it has built it has installed all the dependencies that we mentioned in the requirement.txt, and then it made an image out of it and it pushed into the internal registry that is internal to OpenShift Docker registry. It can be an external registry also. It is pretty flexible in integrating with other external systems. So image is built out of the application source code, and this image is deployed as an email service. Okay. The same thing what I've done here in the console can be done using add to project, and then go to Python 27 and give the name email SVC, and then give the Git repo that I mentioned here. So the same Git repo that I have here, this can be placed here. And in the options, you can mention what is the context directory which needs to look into. All these environment variables can be set here. So resource limits, environment variables, all this can be set here. So the thing is, all the things that you can do from the UI, you can also do it from CLI as well. And this email service is internal to this project and internal to the Kubernetes environment or OpenShift environment here. So that way, this email service is not exposed outside, and it is very secure. And if you want to really expose this outside, you can just click on create route and then click on create. And this, you will have a domain automatically created for you uh, on top of the main domain. And this can be consumed outside. And you can see the email API is working fine. So this way, you can choose either to expose the service outside or not. Okay. With this one application, I'm going to check the comments again to see if anyone has any questions. Okay. All right. So let's move on. And the next thing is email service is deployed. In the same way, I'm going to test the email service once. I'm going to make a curl request, which basically has to and from to address and then message, and the content is application JSON, and this is running on uh, micro. Okay, so this should trigger an email because I have already deployed the email service. So this triggers a email to my email box. So this has sent a email. Let's check if email has been sent or not. You can see this is a test email that I've sent. This is a test. That's what I sent. So email has been sent successfully. So the email microservice is working fine. And the next thing is deploy. The next thing is to deploy. This part is done. The MySQL part and the email API is done. Next thing, we'll deploy the users API in MongoDB. So it's very simple to deploy databases and applications. That's what the funda is here. The next thing is deploy MongoDB. So for MongoDB, you need to tell that you want to deploy a MongoDB, and the username, password, admin password, and the database is as follows. So this creates a MongoDB onto your OpenShift cluster. So this started deploying the MongoDB service here. MongoDB is ready to be consumed. The next thing is the users API, which is built in Node.js, needs to talk to the MongoDB and as well as the email API here. So it needs to talk to MongoDB and the email API. So you need to have environment variable set for MongoDB communication and as well as the email API communication. Okay. So you can see here the OC new app command, and the context directory is Node.js users API. That's where our source code is on the repo. And fetch from my Git repo, which I have already exported. This is a DB service variables, all these are, and then the email application API. So you can see this is where my email application is listening, right? You don't need to give the full URL for internal communication. This won't go outside and then communicate inside. So you just need to mention the service name, email service, and it starts communicating with the email API. So the next thing is deploy users API, Node.js API. If we look at the Node.js users API, you have package.json, which basically defines what are the dependencies for this Node.js API. And go back to the build process of the user service here. you can look at the logs and identify that it's fetching each of the dependencies and it is trying to install those dependencies. And after the installation is done, it will basically build a application image and deploy into the internal Docker registry. Okay, so while this is running, let's move on to other uh, modules. I need to expose this service because this user registration service needs to be communicated by the front-end PHP application, and then it needs to create users. So that way I want to expose this service. For exposing service, you basically mention OC expose. SV is a service, small notation for service, and the user registration service which you have already defined. So this creates a route uh, in OpenShift. So this has been exposed and it creates a route here. So you can see user registration service route has been created. Okay, this was not there before. And the next thing is the Twitter feeds API. So the Twitter feeds API uses the context directory of Java Twitter feeds API and uses this image stream. If you don't mention this image stream, it will identify what kind of image it needs to use based on the pom.xml that you have defined inside the source code, and it deploys based on that. So let's go back to Node microservice on OpenShift, go to Java Twitter state here. So there is a pom.xml file here. Based on this pom.xml file, it will try to identify what base image to use and tries to deploy on that. So it's pretty smart enough to, the CLI is pretty smart here. I'm going to deploy this Twitter feeds API, and I will also need to expose this service. Okay, let's see what is going on inside for the Twitter's feed API. So in the build process, go to the logs, and you can see it has read the pom.xml file and it tried to download all the Maven dependencies here, and it builds a application out of it. So by default, if you configure your application in a specific format, which is a very generic format outside in the world, those formats can be read by OpenShift, and it tries to build application out of it without you worrying about how to deploy and all. So this user registry service is up and running. Let's wait for the Twitter feeds API. Meanwhile, I'll have a quick look on, yeah, does the expose command automatically configure a load balancer? Yes, it will configure a load balancer automatically. So if you have multiple containers running, those will be load balanced automatically by the expose command. All right. Um, Kubernetes use the native load balancer take on Google Cloud and AWS automatically. Does this happen in OpenShift? So Trevor, the XJ proxy, the router which I have mentioned, is pretty configurable. OpenShift also supports the external load balancers such as F5. If you don't want to use the HA proxy that is inside OpenShift, you can definitely use F5 load balancer. It has APIs which communicate with F5, and it automatically updates those rules inside the F5. Nginx, I'm not sure at this point, but I believe it's only supports F5. Okay, thanks. So the Twitter feeds API is deployed now, and okay, it's still in deployment stage. This is a Java app, and it takes some time to come up because Apache needs to boot up, and the build process also takes some time. Meanwhile, let's go to PHP front-end app that we need to deploy. We'll test this app once it is ready. Meanwhile, we'll deploy the PHP app that basically deploys the UI, like HTML pages. The context directory for this is PHP UI, as we have seen on the repo. Okay, and then I'm going to deploy user registration survey front end. So you can see here the user registration service has taken two environment variables. Sorry, that is user registration service, because it needs to talk to the user registration service and create a user. That's when we are using the environment variables that we created initially. And also it needs to talk to the Twitter feed API to get the tweets. And this is how it will be able to communicate with the feeds API. All right. So I hope this makes sense, because it needs to talk to the two services. That's how we mention these as environment variables. You might be wondering, like, we are mentioning those passwords and all with environment variables. Typically, that's not the use case. For simplicity, I've used those inside environment variables. But Kubernetes and OpenShift has concept called as secrets. Secrets will basically hide all the sensitive data from the command line. So this is just for the demo purpose. I have shown you inside the environment variables. Okay, so the Twitter feeds API is up and running now. Um, it shows service unavailable because even though the service is up, it might be bringing up the inside the Apache or JBoss container up here. So it's still not started the JBoss container. Now we can see it has startup is complete, and if you hit this, it will be ready now. Okay, so it doesn't show anything here, but if you test, this is the path where I am going. Um, This is my user Twitter handle. And if I click on that, it should show me my last few tweets, right? So it's showing it is working perfectly fine. So all the services that we see are functional, and we need to deploy the PHP front end. And you can see the front end is also ready. User registration front end is ready. And I want to expose this as a route because this is where I'm going to see the UI. Okay. All right. So the UI is up. I have the user registration screen. I have foobar, or I'll keep one email, my email for simplicity. I'll keep the default password same. And let's give my username here. Okay. And register now. Registration is successful. When the registration is successful, it should store the data in MySQL, and also it should send an email. So let's see if my email is triggered or not. So I should get a sign up complete email. Yeah. So I got a sign up complete email. This is pretty simple email. So I got an email that works fine. And I will log in with those details I have. Login is successful. I got a token, get friends list. I got a button for get tweets. When I click on tweets, I got tweets for my Twitter handle. Okay, so the whole process took about 20 to 25 minutes, right? And this is how you can deploy very big application in very short time, and also in a very efficient way. And consider that if your front end is facing a lot of traffic and you want to scale your front end services, scaling in scaling in OpenShift is as simple as clicking buttons here. So I just click up arrow, and it scales the number of pods to 3. Okay, and you can also see in the view here. So my 3 parts are here, right? So my user registration service is deployment configuration is this. Like externally, I have exposed this as a route, the user registration service, and this route hits a service because this is how they communicate. Route handles forwards the traffic to service, and service will route traffic to each individual parts. So this is one part, second part, and third part, because we have scaled it thrice. If we scale it multiple times, it automatically load balances between those parts. And this is a replication controller inside OpenShift, which basically makes sure that at any point of time, 3, like if you mention 3 as a replication number, it will try to make sure every time there are 3 pods inside um, OpenShift running for that application. So this is a process that monitors the application state, container state, and this is obviously the deployment configuration for this whole thing. Okay, and let's try go and kill one of the pods, say user registration pod. Let's kill this pod and see if OpenShift is really taking care of the replication part. Okay, so currently, if you look at overview, we have for user registration, we have about 3 pods running. And let me go and kill one of the pod and see if it makes any difference here. So three pods, I'm going to kill one pod. Okay, you can see instantly the count has reduced. So it is trying to bring up to the number 3. Can see it tries to bring it to the specified number which you mentioned. So 3 again, it has come up to 3 again. So by this you can make sure all the environment is up and running. You won't be getting any late night calls for server down and all. So all you need to take care is let's just make sure OpenShift is up and running, and rest everything will be taken care by OpenShift for keeping up your environment. So the same thing you can see from the command line, OC get parts. So you can see these are all running parts. And you can also see some of the build parts here. So what OpenShift does is when you build your application from source, it tries to keep the build out of your application instance. That way it won't pollute the application container. All right. So because if the build process generates a huge amount of logs or some pollution, those won't go inside your application image at all, because the build container itself is different from your running application container. That's how it keeps it very simple. And you can also see some of the build and deploy pods as well. So your build pod is different, your deploy pod is different, and your actual running application pod is different. But when build pod and uh, deploy pod are completed, they will be cleaned up, so they won't be available there. So it's as easy as uh, running few commands to deploy complex applications here. So we have basically deployed 2 databases. We basically deployed like MySQL, MongoDB, and 4 other apps in a very short time. Okay. With that, if you have any questions, I can definitely answer. You can unmute yourself or ask in chat. Does OpenShift support TCP transport? So TCP transports, yes, it does support TCP transport, but in my personal experience, so say if you want to deploy a Kafka cluster, it's pretty much supported inside the OpenShift environment because it uses TCP ports. But if you want to expose it outside, there are some tweaks that needs to be done for it to expose it outside. Uh, Based on that experience, I would say it does support TCP, but there is it is not out of box. You need to change a few configurations for that. Okay, cool. Yeah, and if you want more information on microservices, our colleague Christian Posta has written a book which is going to be released tomorrow, I guess, um, or in the next Red Hat summit. So this is microservices for basically Java developers. This is specifically pointed towards Java developers. It's written by Christian Posta. He's a Apache Camel contributor. very very great guy. You can definitely look for his book. Um, he has he has some examples around Netflix OSS on top of Kubernetes and also OpenShift. So how you use your Netflix OSS microservices on top of Kubernetes, and also it's specifically targeted towards Java developers because that is where the most of the developers are. Um, yeah, you can look forward for this book. I'm going to share these slides on this first page. There is a Bitly link. Yeah, this is where I have these slides. OpenShift hyphen microservices. You can definitely go. And if you have any questions, feel free to give me on Twitter or email me. I can definitely answer those. With that, I want to give you one um, short demo on how to install OpenShift. So the best way to install the origin, which is the upstream version of OpenShift, the community version of OpenShift, is using a Vagrant image. So if you have Vagrant image already, uh, if you have Vagrant installed already, there are two simple commands that you need to use. These are Vagrant init. The Steve Zero, he's our guy who basically built this image, and OpenShift hyphen origin, and just do Vagrant up. So this will basically deploy a OpenShift cluster that is obviously a Kubernetes cluster as well. And you need to hit this URL 10.2.2.2 That is what I'm using now. So this IP is configured in the Vagrant file. If you want to change, if you want to use a different IP, you can definitely change in the Vagrant file and then uh, use it. But otherwise, it is as simple as just two commands and then hit this URL. The default username and password for this is admin and then password. So the default credentials is here is in this web console, admin and then password. All right, so that will give you very quick jump start to OpenShift. Okay. Um, right. Anybody else have any questions? Okay. So it looks like we are good. Uh, Again, thanks everybody for joining. Nick, do you have anything to add?
No, I was just about to say the same thing. Thanks everybody for joining. If you have any questions afterwards, I don't, can they reach out to us via the meetup site, Chakre?
Yes, for sure. Yeah.
So
Right.
yeah, that I would encourage you guys to ask all the questions you can. I posted a couple books. There's a new book out called OpenShift for Developers that brings you through some development scenarios that might help out, and also another somewhat deep dive on Kubernetes that I also found helpful. It's a really quick read, but it's very informative. So I encourage you all to check it out.
Right. Okay. Thanks everybody. See you soon.